Hi, I'm Sean Gannon, and this is Minute Math, and today we're learning about create a new function by composition of functions.
Minute Math, when you need help you use Minute Math.
So we've talked a little bit before about this, and a common expression for a composition of function is this. F of g, we have two functions, of x is equal to f of g of x. Okay? So what we're saying is we have read a compositional function f of g of x is equal to f of g of x. Same thing, right? But you take that g of x function and it's a function that goes substitute into the x value, let's say, of our function of f. Okay? So we can see an image here of that. We have g of x is the output of g, or is the output of g, is the input of f. Okay, so the output of g becomes the input of f there, and x is the input of g. So x goes into g, it gets an output. That output goes as the input into f of x, and that's our composition function. Okay? Alright, so let's go with a example here. Definition. Compositional functions. When the output of one function is used as the input of another, we call the entire operation a composition of functions. For any input x and functions f and g, this action defines a composite function, which we write as f of g, such that f of g of x is equal to f parentheses g parentheses x, two more parentheses. The domain of the composite function f of g is all x such that x is in the domain of g and g of x is in the domain of f. So it has to have the domains of both there. It is important to realize that the product of functions f times g is not the same as the function composition f of g of x, because in general f of x times g of x is not equal to f of g of x. Alright, so let's get into an example here. So, number 2. Using provided functions, we want to find f of g of x and g of f of x. Alright, and we're going to determine if the composition function is commutative. So we'll start with this first. F of x is equal to 2x plus 1, and g of x is equal to 3 minus x. Okay. So let's first start with the first part, f of g of x here. Alright, we're going to substitute g of x in for f of x. So this is how I like to do it. Let's write f of x 2 times, but I'm going to give a little space for x. I'm not going to put x in, plus 1. So hopefully you can see there's a space there. That's what the x value is. And what we're going to do is take this g of x and plug that in. So we can kind of see it here. Plug that in, 3 minus x. So now I'm plugging g of x in for the x value here on f of x. So that whole function. Now we simplify. 2 times 3 is 6. 2 times a minus x is a minus 2x plus 1. Combine our like terms. 6 and 1 is 7. So it's 7 minus 2x. Alright. Let's find the other one. G of f of x. So same idea. We're going to start with g of x. 3 minus, and instead of x, I'm going to put my parentheses. And in this case, I take that 2x minus 1, and I'm plugging it in there. 2x plus 1, excuse me. Simplify, distribute the minus sign, minus 2x minus 1. Okay. Then 3 and minus 1 is a 2. So we have a 2 minus 2x here. Okay. We could rewrite that if we want as now minus 2x plus 2. But what they're asking us is this function operation commutative, right? What's that really meaning is g of f of x, is that equal to f of g of x? And you tell me, are these two equal? No, they're not. So they're not commutative. Okay? Alright. Let's go erase this and we'll dive into the next example here. Okay, so now we want to interpret composite functions. So we're given this. The function C of S gives the number of calories burned completing S sit-ups. And S of T gives the number of sit-ups a person can complete in T minutes. Interpret what C of S of 3 is. Okay, so a few things they tell us, right? So we have our functions C of S. All right, C of S is calories burned. So quick note, calories burned. Doing S sit-ups. S of T, that's my really bad S, leave it alone, is the number of sit-ups a person can do in T minutes. What is C of S of 3? Okay. All right, what is that? That's the big question. What is C of S of 3? So with user knowledge of composite functions, S of T, or what is S of 3? Let's start with that. S of 3, the inside. What is S of 3? S of 3 is a person, is whatever that is, that output. Okay, S of 3 is, well, in 3 minutes, the input is 3 minutes, the output is how many sit-ups that person can do in 3 minutes. Okay, so S of 3 is number of sit-ups, we don't know what it is, a person can do in 3 minutes, right? So that's S of 3. Oh, I gotta put it on parentheses here. So the number of sit-ups a person can do in 3 minutes is some number. We don't know what it is, but it's some number. And that number goes in to our function C of S, and that's the number of calories they're burned doing those sit-ups. So what we can do, we can interpret this whole thing, is this whole function is the number of calories a person burns in 3 minutes, or with, of sit-ups. Okay? So we can recap that here, right? We have S of 3 is the number of sit-ups a person can do in 3 minutes. Okay? That number gets plugged into our C of S function, and that gives us a total number of calories. So we have the total number of calories the person burns with 3 minutes of sit-ups, and it kind of jumps through the number of sit-ups. We don't know what that value is, but this is how we're interpreting everything. Okay? All right. Let me erase this, and we'll dive into the next example. Okay. So we're given this one here. We're investigating the order of function composition. Suppose f of x gives miles that can be driven in x hours, and g of y gives the gallons of gas used in driving y miles. Which of these expressions is meaningful? F of g of y or g of f of x? So let's just see what each one of those are. So just so we can see here, f of x is number of miles driven in x hours, and g of y is the gallons of gas used in driving y miles. So what we're going to do is interpret what the two values are. What are f of g of y, and what is g of f of x? Okay, and which one's actually meaningful? Okay. All right. So, well, our first function, right? F of g of y. So g of y is the gallons of gas used in y miles. So we have, and then f of x is the number of miles driven in x hours. Interesting. The number of miles driven in x hours. So what we're saying is the output here. So what is the output? So the input is Y miles. The output's the number of gallons of gas. So if we interpret that in a sense, we're saying, okay, our function f, we're plugging as input the number of gallons of gas. And driving Y miles. Okay? Well, that's kind of weird, because then what's the input for f of x? The input is the number of hours, right? So if the input's the number of hours, that'd be weird. We're finding a function where we're plugging in the number of gallons of gas into f of x, which is the number of miles driven in x hours. We're plugging gallons into this value for x hours. Wouldn't make sense. Let's try the other way. What is the output of f of x? Well, output of f of x is a number of miles. Okay, so we have number of miles driven. So there's number of miles driven in x hours. So the number of miles driven in x hours, so our input is x hours, puts into that function, which is the g of y function, which gives us an output, f of x, an output of number of miles, which then the number of miles is the input of g of y, which gives us the gallons of gas. So the second function actually makes sense. The output of f of x matches up with the input of g of y. So this one here makes sense. And what they're telling us here is that g of f of x tells us with our first input is x hours, or gives us the number of gallons of gas, gallons of gas used in x hours. When it's all said and done, we input the number of x hours, that gets converted to how many miles we drive, which in the other function tells us with that information how much gallons of gas did we burn. Okay, kind of a long way through, but we got there. I hope you learned something here on how to create a new function by composition of functions. If you did, please subscribe to our YouTube channel and like this video. This helps us make more free math lessons for you and for everyone else. And as always, thanks for watching.
Minute Math. When you need help, you use Minute Math. Minute Math. Minute Math. When you need help, you use Minute Math. MinuteMathTutor.com.